So here's problem number 43 from section 8.4. We're going to find the area underneath this curve in the first quadrant, and we're just going to acknowledge that that this curve looks like this. It has a 0 when natural log of 1, when natural log of x is equal to 0, and that is at 1. And then after that, it goes upward, but as x squared gets much, much larger, it's going to fall towards the axis. That natural log of x is not going to be able to get big enough in order for it to stay above the axis for very long. So the area in the curve that we're, in the first quadrant that we're looking for is really the integral from 1 to infinity of the integral of natural log over x squared dx. Now, I believe the best way to solve this problem, to evaluate this integral, I'll do this as side work. Natural log times, and I'll say this is x negative 2 dx. I believe the best way to do this is integration by parts, where u is the natural log of x, dv is equal to x to the negative 2 dx. du is equal to 1 over x, and v is going to be equal to, let's see, add 1 to the exponent, reciprocal. And so the rewrite of this is going to be negative natural log x over x minus the integral of negative 1 over x times 1 over x, and I forgot the dx here, dx, or negative natural log x over x plus the integral of x to the negative 2. This is negative natural log over x plus, so we add 1 and reciprocal, so negative natural log x over x minus 1 over x plus c. I'm going to rewrite that one more time, and that is the opposite of natural log x plus 1 all over x plus c. So let me go ahead and first of all change our improper integral to the limit notation and say that this is equal to negative natural log of x plus 1 over x as evaluated from 1 to b, or this is equal to the limit as b approaches infinity of negative natural log of b plus 1 over b minus a negative natural log of 1 plus 1 over 1. Super plus there. Okay, natural log of 1 is 0, so this is going to be just a plus 1 out here. But what's happening over here? We got a natural log of b on the top, b on the bottom. I might want to do a little side work and just to evaluate that limit. So I get the limit as b approaches infinity of natural log b plus 1 over b. I recognize that this is indeterminate in the form of infinity over infinity, and therefore I can take I can apply L'Hopital's rule, the limit as b approaches infinity, getting sloppy here, of 1 over b over 1, which is the limit as b approaches infinity of 1 over b, which is equal to 0. So I say that that's equal to a big old 0, and so that our final answer is 1. The area under that curve is 1.